Hello everyone. I have this slide into my face, so I don't see you a lot, but I would like to welcome you. And together, my name is Mateusz, and together with my colleague Jakub, we are going to talk about how to bypass malware detection mechanisms deployed in online banking. Okay. Thank you all once again for coming, because it's, I think, quite late. So, what we do, we are both pen testers at Securing Company. It's a company based in Krakow. Before that, we both have experience as software developers. In our current occupation, we mostly test, as I said, we are penetration testers, we mostly test e-banking sites, mobile applications, web applications related to financial sector. We have tested multi-factor systems, multi-factor authentication, voice authentication systems. Also, we did some malware analysis post-mortem, and we helped our customers to stop ongoing malware attacks. Okay, that would be short about us. This is the agenda for today. We are going to start with a small introduction to give you core concepts related to malware, to anti-malware, to start to discuss. Then we will discuss potential attack vectors on script-based malware, script-based anti-malware solutions, and then we will go through recommendations for improvement in such solutions. And later on, we want to discuss with you our work. So, I pass the mic to Kuba, who will do this introduction part.
Okay, so first we have to answer a simple question. Why this topic is so interesting? Well, why is it hard to protect online banking applications against malware? Well, first of all, antiviruses like a standard standalone executables are not really reliable. You can send, for example, the virus file to VirusTotal or any other service, and you can see that not every antivirus catches it positively. So the second thing is that users are really lazy. They do not want to install standalone executables, click 10 times, then use space or the disks and anything. Well, the question for you, are you lazy? I would like ask like a simple question. Supposing you are sending a transfer in your online banking applications. For example, it's invoice for telecommunication services. You open your invoice, you copy your bank account address. On the first page in the bank, you just paste this address. Then you type your amount. On the second page, you have to pass the code which you receive on the second channel in the SMS. What do you do? What do you compare? Of course, you compare the amount, and you compare the banking address with what? What do you compare? With the screen. Then you're lazy. Then you're lazy, because some of the malware can change what you see on the screen because it's in the banking, in the browser application. What you should do is actually comparing it to the paper invoice, or at least invoice in the PDF file, right? Okay, so there is a market gap for new solutions on the market. The solutions which work in the browsers, which are clientless, in the mean of you don't need to install any standalone application. You are just a simple client who open the banking website, and all the magic stuff, malware detection mechanism, is done automatically. And the last thing is there is a lot of money in banking industry. We all know that. Okay, so how does malware work, or actually how does some of malware work? First of all, it interacts with the browser using web injects. Most of banking malware does it. They use web injects, which is small JavaScript code which is included into the banking website. It's done actually on the client side, so data is intercepted between the server and the client. Sometimes it works the other way. For example, by changing the process memory of the browser, by changing banking account address, you know this malware. So what is the purpose of banking malware? Of course, it steals credentials to the banking application. It changes transaction data to steal the money. And sometimes it automates attacks by, for example, clicking, simulating user clicks or actions. So how does JavaScript-based malware detection works? So the aim is to detect malware presence, and it can work on different layers. So here is like a simple diagram of the data flow when a user opens the banking website. So the malware detection mechanism can catch signatures of the HTTP response from the server to the browser. It can fingerprint the JavaScript and the DOM block in the browser. Of course, it can fingerprint user and browser behavior. I mean, the speed of clicking, the speed of typing letters, and mouse movement. That's how Google reCAPTCHA now works. And of course, in the back, there is some fraud detection system which analyzes transactional data, and the malware detecting system can work also there. So the action of this solution is to drop or mark sessions as compromised. What are the limits of this solution? These are the methods I mentioned before. Here I got a simple graph of marketing and auditability of these solutions. And by marketing, I mean marketing power of saying such phrases. So when a marketing person goes into the bank and say, oh, our solution uses HTTP response signature, and people from the bank think, okay, why not? And the auditability of this is very big. Like, you can of course check which signatures, which malware is caught by these signatures, and so on. But when the marketing person goes into the bank and says, okay, we've got a fraud detection system which uses machine learning, deep learning, and big data with cloud systems, APT, then the marketing of this is, you know, you will buy it, don't you? But the auditability of this is quite hard. Recently, we've been testing some voice recognition technology. Actually, it's voice authentication to the bank. We found some vulnerability. We've been able to bypass authentication, voice authentication once. And for the vendor, actually, once is okay. You bypassed it once. Our machine learning, big data, cloud computing system updated to your attack, and now we are not vulnerable. But okay, come on, in case of banking malware, I think once is enough. Okay, like a small disclaimer, we do not represent any vendor, we do not create such solutions. We can consult one if you want. We want to show mainly implementation and architecture errors, not the whole idea of script-based anti-malware. And we want to talk about what can be done to get these solutions better. So what are the attack vectors for a client using online banking applications? Our approach of testing was to feed the browser with some malware, analyze the JavaScript of this malware detection solution which comes from the web server, analyze outgoing traffic, and sometimes we had access to the administrative interface in the transactional system. It was, for example, admin console to view logs and see the alerts of the solution. So our first idea was really, really simple. It's not magic, really. We were intercepting HTTP traffic on a clean machine and on an infected machine. We did some action. Let's say the action was to log in into bank. What we've seen, we did some JS analysis, and we've seen that on the infected machine, there are some different paths, different subdomains. There were a lot of base64 strings, which didn't appear in the clean machine traffic. And we've seen some encryption, RSA, asymmetric keys, and so on. So what we did, actually counting this HTTP request, we've seen that on the clean machine, we've got just simple one, action. And on the infected machine, we've got something more. So what would you do if you are operating a malware, actually creating a malware, and you see that your malware on the infected machine creates some more HTTP requests? What would you do? I mean, improve your malware to not get caught, yeah? One more time? Yeah, okay, we already analyzed. I mean, we analyzed and we've seen that this little bit stronger line is the request. We think that it is, hi system, there is malware there. Anybody else? Yeah, hide, like cut. So just disable this, delete this HTTP request, and actually, like if it bleeds, we can kill it. So we just, for example, change DNS of this subdomain, or just cut the HTTP request. We can do this in JavaScript, no problem, and it's bypassed. So, like for example, for Zeus family malware, disabling this HTTP request, this additional HTTP request, is just like one line of code. And it shows us a bigger architecture problem. Because actually, like on the business level, this solution works by sending red light. So the anti-malware magic script sends a red light. This machine is infected. Why not send the green light instead? So check all signatures, check if there was malware, and finally send, oh, this machine is purely no malware. Yeah, we call it adverse inference. Okay, so once the malware was spotted, we found the third vulnerability in few solutions. In this red light request, there was an alert. The alert contained some data, the login of the user, the time, and the behavior. Sometimes in the behavior it was said it is suspicious, sometimes it was even the name of the malware. So what would you do? For example, manipulate this request. If the browser sends the request of the alert, why not change it and says, okay, this machine is not infected. It's machine of user 2 who is infected. And actually, it worked. It worked pretty well. So in the admin interface, when we viewed the logs, you can see that there was no suspicious activity from user 1, but from the user 2. Okay. And the last thing, I think most funny for me was that first things first. So if this anti-malware magic is a big bunch of JS scripts, it takes some time to load this JavaScript, right? We've been testing this solution for such a long time that I've been doing some. Well, it was manual testing, but I was really doing it fast. So clicking, logging, typing password, and at some point on the infected machine, I logged so fast enough that this anti-malware magic didn't work. It's because of the red-green architecture problem. The JavaScript didn't load, so I was able to log on the infected machine with no alert. Well, yeah. Now I pass the voice to Mateusz. Thanks.
Okay, so now we're gonna to deep dive into how this signature stuff works. Basically, on the client side, we have some script, which is JavaScript code, is known to us as a user because this JavaScript is downloaded from the server. Actually, you can see it from the browser itself. And on the other side, on the server side, we have some API related to this solution, okay? And we have some signatures present on the client side. We'll discuss it in a moment. This is one part, and second one is some reasoning engine, something which decides we are going to send this alert or not. Sometimes it was related to some encryption, asymmetric RSA encryption. And still, here, encryption is okay, but you have to remember that if JavaScript encrypts anything, the public key is also present there. So as Kuba discussed this example, the message with the login user 1 and user 2 was encrypted, but still we had the encryption key. So the message itself cannot be trusted in case of the values, let's say, the user, right? And what do you think about code obfuscation? Okay, that's one thing. So I'm going to say I'm the fan of code obfuscation because you have to understand the purpose of obfuscation. It has to make more difficult, more time-consuming, more resource-consuming for an attacker, let's say, to analyze, to understand what's going on. And here, having this slide, we have signatures, so what we are looking for, and the reasoning engine, how actually it works, embedded on the client side. So I think we have to protect it. We have to make it hard to understand the code through the obfuscation itself, and also through some hiding in plain sight also, to embed in some real JavaScript inside the application. In case of code obfuscation, we found solutions which either didn't obfuscate code at all, or it was easy to bypass the code, obfuscated code. But still, some applications, if you look into the JavaScripts related, the obfuscated code was quite easy to spot because it was different. All of the rest of the code was not obfuscated. Small parts was, and that what interested us there. So, simple obfuscation, some hex encoding, base 64 strings, some quite easily to decode JavaScript. What we recommend in case of obfuscation is to use multiple JavaScript obfuscation technique at once through your scripts and to change them. For example, some of the solutions we considered generated each time the JavaScript which were downloaded to analyze this to seek for signatures was downloaded every time the page was loaded. So you could easily interchange the obfuscation techniques to make it hard to understand and make it hard to automate the obfuscation. Of course, evil had to be there. Speaking about signatures, we found two approaches, signatures server-side and client-side. How does signature server-side work? So basically, user requested some site. He navigated to his banking site, and he got all the HTML, JavaScript, CSS files. Also, he got this detection script, which signatures were really regular expressions which extracted parts of the rendered HTML site, and those parts, those fragments were sent back to analyze to the server. So here, the signatures maybe they weren't easy to see, but some of the analysis was done on the server side, but still we know which parts of the website were analyzed here. And second approach, it was signatures client side. So same as before, user navigated and got all stuff, all HTML, JavaScript, CSS stuff he needed, and also our malware detection script. And he got signatures embedded as also in the script. What is signatures? It was some constant string and functions which were the JavaScript related to signature were looking for in your, for example, window object. Some constant function names, variable names, sometimes also the type of the object related to given name was also checked. And then signatures were analyzed and the response were sent back to the server. So actually doing, as I said before, code deobfuscation, we were able to see really which signatures, which JavaScript objects related to web injects, the applications, the anti-malware mechanisms was looking for. And one other thing, there were two approaches, because here we have one phase, two phases. Initialization phase, when the mechanism is started, and then the reporting phase, when the results are sent back to the server. So we had two phases actually, and you could either, as Kuba said, block the first thing, the initialization, and secondly, you can here you can also manipulate what was sent back to the server. And one of solutions we tested, it was like this. There was an, let's say, array of binary numbers, and each signature check was related to changing or not, depending on if the malware was found or not, changing the one value in this array, and then this array was sent back to the server. So basically we had, if there were no malware present on the machine, we had actually the result, the array was sent back to the server as it was sent to the browser. So nonetheless, we had malware or not, we could also forge the "we are clear" message to the server and send it back. So in case of client-side signatures. Now, moving to the last part of our talk, to conclusions. We divide into two groups. For potential buyers of such solutions, we think it's a good approach to have, to build, or to buy this kind of solution, because I think in the end user will get the malware on their station. So we have to somehow protect your business. And this is okay. In case of buying, don't believe in military-grade technology. Don't listen to marketing bullshit. Ask for details, how it works, how it really works. Request also a live demo on your infrastructure. Try to see how easily it will merge into your existing web applications, into your existing monitoring solution. This is also, such solution is one layer of defense. You cannot forget you have to have strategy, right? You have to have people watching it. What is also most important in such solution, I think, not the malware detection rate, which it holds, but I think one of the most important things is when how quick this solution can respond to an ongoing malware attack, which it doesn't stop at this very moment. How quickly additional signatures can be deployed to stop something which is hurting you at the very moment. Okay. So also we think it's important to gather knowledge inside, not only have it, but understand how it works, to improve it yourself. And to trust, but verify, right? You have to trust, it works, but trying to check. Okay, going to the vendors. I would like to say again that all the vendors we found vulnerable, we reported to them, and we did it in a responsible disclosure manner. So, as I said before, this is good path to build such solutions, but still you have to remember that we have browser, servers, HTTP, HTML, JavaScript, and all that good and bad which comes with it. So Remember that, remember how JavaScript works, remember the pluses and minuses of code obfuscation. Think about your architecture, try to be one step before your potential attackers. What's next? Actually, we finished some time ago a paper which can be downloaded. We can analyze, dissect, help you build a solution like this one. If you're interested, please find us. We are here at the conference at our stand. You can write an email, tweet to us, whatever, however, approach us however you wish. And now, questions. If you have any. I don't see hands because of the light. Just one, maybe. I know it's light, yes, please.
Just a quick question. How reliable is it to detect signatures? Like, if I drink a Red Bull, is my signature of how I use my online banking very different? If I'm tired, drunk, whatever else, does that fool it? Does that stop me using online banking?
No, it's unfortunate. You have to use it. I prefer online banking instead of going to the bank office. So in case of, are we as users secure or not? I think most of the time we are secure, right? So let's say it will work.
No, actually, right? it's future of anti-malware work and actually malware detection. Like now everything moves into the web. Everything is in the browser. You've got like some time ago you had standalone clients with banking and so on. Now everything is in the web. So you have to trust these solutions or maybe create yours better. Yeah.
Hi, I have a question. How efficient are these tools? I mean, from your test, how many times can they detect the malware? Let's talk about Dire and some other malware which is now...
If you are talking about rate of malware detection, we don't have like an arsenal of all malware created. Actually, if you want to get infected by a specific malware targeted for a specific bank, it's not very easy. You don't go to Google and type, hey, infect me with Zeus targeted to let's say ABC Bank. It's not so easy. We don't have an arsenal of malware. Actually, I have to say we are not strictly malware researchers. We do not do like a deep reverse engineering and so on. Most of this work is actually web penetration test because it's a web solution.
Yes, it's still another piece of software which is added to your web application, e-banking web application, which could still have vulnerabilities. No, specific, but still.
No, but the detection rate for malware is actually 100% for this malware for which the anti-malware solution have the signatures, right?
So it's like an antivirus, it's not really efficient.
Yeah, well, sometimes it covers 90, the other solution gets 99. Well,
yeah, this is pretty good analogy to antivirus, right? It's as good as its signatures are, and this very moment, yeah.
So if I would be a bank, would you advise me to invest in such technologies or find some different alternatives in order to secure my clients?
Yeah, well, that's a question if you are a bank with big funds which can actually send the work to the like software as a service, which is this kind of solution, or you want to create your own crew, your own team working on malware. Actually, in our opinion, I think like a small team of 5 people or maybe a little bit more is enough to do all this work by the bank itself.
Okay, thank you.
So one more thing I would like to add to what my colleague said. I think building an in-house anti-malware solutions could have one advantage. I think if, let's say, malware creators will start to targeting such solutions, I think they will start with something which is mainstream, like which has biggest market adoption. And if you have it in-house, I think you could be a little bit safer. because you did it on your own, you had it built on top of your application, right?
But there are also some cons. Like we've heard from one of our clients that if the malware operators or malware sellers see that this bank is protected by ABC anti-malware solution, they do not touch this. They do not touch this because it's too much work to them, and they rather attack a smaller bank which does not have this solution.
One more question. Have you used just during this analysis just a useful tool or just cool tool to analyze this obfuscated JavaScript code? We know sometimes it could just blow up your mind just analyzing such things.
Actually, in case of Java obfuscation, we did it by hand. It was, as I said, it was quite easy. It was sometimes one or two techniques used, and the script wasn't big enough to try to write some tools, right? I have, let's say, a few hours, knowing, of course, before the obfuscation techniques, but it wasn't a long script, and it was quite easily obfuscated. It took me a while to get to the meaning of the functions, let's say, because also the names were obfuscated, but we did it by hand. Let's say, to check some scenarios, we actually create some tools in case of it was burp plugins to, for example, cut communications or to modify the script on the fly, to repeat some tests. But it was, mostly the obfuscations was done by hand.
Well, that's mostly because our penetration tests are mostly manual. We do not use mainly scanners and like automated tools. We prefer manual testing.
Yeah, but some
Yeah, of course. Yeah, of course.
JavaScript codes are so
Yeah, sure. Yeah,
complicated, so it's not
I think we use
possible to manually analyze them.
Yeah, that's right. I think on the very first step we used JS Beautifier.
yeah, that was one tool to make it more pretty look, right? But that was not really the obfuscation, right? It's make it look prettier.
Sorry, could I ask a follow-up question? If you assume that every user has a unique pattern of how they press keys, how many spelling errors they make, how they move their mouse, could you use a similar signature-based technique to figure out, maybe not whether I'm malware infected, but whether someone else is using my account because they don't have the pattern of how I use my computer and my devices?
Yeah, well, that's what happens now, I think. Like, we've seen some solution which, like, for example, Google reCAPTCHA now. It measures some speed of clicks and so on. There are many new authentication methods for the banking industry, like voice authentication. We had a lot of fun testing recently voice recognition technology. Like my colleagues went crazy when I was speaking all the day, log me into the bank ABC, log me into the bank ABC.
Damn you.
There were also some funny stories, like one of the options in this voice authentication software was to ask the bank how much money you've got. In Polish, it's ile mam pieniędzy, and it rhymes with ile tam jest nędzy.
How poor I am.
Which is how much poverty is there. And it worked, if you say this.
Quite funny, yeah.
So I think, I haven't seen such solution which will authenticate user by measuring browser behavior, but maybe it's the future.
I think right now there are tools which allow you, in case of these solutions, which allow you to say if there is a real user there or some script which do this automatically, but still we saw some cases when there was no automated tool to extract, for example, money from the compromised account, but there was some operator somewhere, the real human which was doing the transfer himself. So in case...
With a remote desktop.
Yeah. So in case I'm not sure how... Oh yeah, one other thing. We were stumbled with something funny during our malware analysis. We found out that because this case was in Polish, let's say financial institution, and we found out one quite easy to spot problem during our analysis of malware. most of the users do not change in Polish, in Poland at least, do not change the language to English before they starting making transfer. And that piqued our interest, and it shows only those accounts which were compromised changed. The first thing they did after logging, changed language to English. So it was easy, right? But quite pattern, quite obvious. Another one, okay.
So following that, would you prefer to recommend behavioral analysis of users' actions in bank, or just provide something like that clientless malware detection system? If you had to choose one or the other.
But mostly what we did, we analyzed those, let's say, script-based solutions which were using signatures. So actually, we didn't bypass any solution which were using really user, which were doing the other thing, right? So I think those signature-based can be good enough, like an antivirus. This is a good way to do it, good way to protect your business from the malware.
Yeah, well, you have to understand the purpose of anti-malware solution. It has to minimize the risk, but do not delete the risk, right?
It won't stop everything, but in most cases it will stop a popular malware family against your institution.
Okay, any other questions? Yeah. Oh, microphone.
What other infections are you able to detect and fight with?
You mean the methods of malware
No.
detection of
What?
specific malware?
Specific malware.
Well, actually, it's not a question to us because we do not provide such solution. But as we've seen, it's actually most, like 99% of banking malware which is operating in real now. You know, actually, there was a slide with some names. I think I took these names from one of the vendor websites.
Nice catchy names, right?
Yeah,
yeah.
Those were some names, but actually, the malware detection mechanism is as good as its signatures. So actually, for most of these solutions, they had signatures for most of operating malware in real.
Yeah.
Yeah.
Hi. Does this malware software has some, did you discover it has some finding false positives? So it's too sensitive that it's recognizing a user as a malware. Did you spot this kind of behavior?
Yeah, one of these solution, I think, relies on the speed of logging. And it caught some automated tools which were logging to bank, but they were not malware. They were some intermediary payment companies which do not want to pay the fee for the bank for gathering transactional data, but they just log into the bank by their own methods. But the other, I don't think so.
To add one other thing, some of the signatures were, let's say, it was for given malware family, it was set of signatures to check. For example, this function, that function, those three strings of given names, and if all of these were found, then the backend server said, okay, this user is infected with ABC malware family, okay? In case of some of them were missing, for example, it found two functions, but only two strings, not three, it generated some alert. Something is not, it was not red light, but let's say yellow. So it's really, it didn't alert the red, this particular one didn't alert, it did alert only when it was certain that given malware is present.
This solution catches signatures like if eval function is there, or a function which does operate on the HTTP, XML HTTP request. So sometimes it may happen that on the bank website originally there is a script which could be caught by this kind of solution, but actually the vendors of such solution analyze the bank website before and create like a targeted signatures.
In case of signatures, you have to be careful because, for example, the user also the developers of the web application can put some names into, let's say, window object, some global function names, which could collide with your signatures, right? And still, having found one function which given, let's say, base64 decode, doesn't mean you have malware. Maybe the users, the web developers developed this function for some good reason, right? But still, you have to test it against your pure, clean web application.
Now I recall a false positive example. In one bank, there was a situation where a bad, like a plugin to the Firefox, I think, or Chrome, injected some code into the banking website. So I think one of the solutions caught this as web inject, but it was not web inject because it was an original web browser plugin. Okay, so thank you very much. If you want to get the follow-up paper, just leave your business card or send us an email. Thanks.